Welcome to a new test and teardown video. This time it's a Danmar RT210. So it's also called a Link 4000. It's an HF, medium frequency transmitter receiver unit for boats, for marine equipment. And this part here is only the transmitter and the receiver, all the fancy bits. The high power transmitter is an external unit that is actually, I think, is a little bit bigger than this. So it's got an external power amplifier, but also a power supply. So this one, you can't really use this one as a standalone unit. You need to supply it, I think it's like 3 or 4 different voltages. And there's a special connector on the back. So I don't know if we will be able to power this up, but there will be a few tricks to do that, I think so. So I will hopefully be able to do that. Other than that, I can say that it should be able to cover the entire 1.6 to 28 megahertz band. And with the transmitter, it can do 400 watts of peak power. But I think this one is there's only a 1 or 2 watt output power drive stage in this one. So first of all, I think we should just open it and have a look at the build style and quality. It is, of course, fully computer controlled with all the nice and fancy readouts, and it can do all the computer things, modern things. It is from 1986, so this one is set 80. Yeah, set 80 based. How nice. First impression, absolutely beautiful. It's made with plug-in boards and a motherboard. Down in the other end, that will be, of course, the CPU section, perfectly shielded. And we got some cables that's going to some different things. It looks like all these cables goes down to the front panel. And there's probably a motherboard connector as well. I think we're gonna go and open some more. The first little thing, I find some missing screws. Over here it's fine, it's a little bit different here with some, we're gonna see what, what's that? Probably some audio output or something. Yeah, it's not in a perfect, fully function condition, I guess. Wow, I got the first one out here. And that is, of course, the different bands. So this is a module where you have a digital interface going to some line select, driving all the different kind of relays. And that switches in and out the different band pass filters, for all the transmit receive bands. That is quite amazing. And that will be this little over voltage. This is a gas discharge for over voltage protection, and this, of course, the antenna input, and then it goes to all sorts of input protection. And there's also a relay that will short the antenna, so there's a 0 volts there, and then it can enable all the different bands. This is also explained here at the front. See here, antenna grounding or open, that means completely disconnected, and then it can go to all the different modulation modes and all the different bands, obviously. Oh yeah, this is a 2-layer board, and top layer here is ground reference for all the different. Ooh, look at that, some coax cables, nasty. And then here the rear side. See, that's of course the digital interface, and then it will drive all the different relays. Quite nice design actually for a 2-layer board. It looks like they have done everything correct here with nice ground, nice isolation and all that kind of stuff. That is pretty good. The only thing I'm a little bit disappointed about is that will be the coax cables. It was initially designed to use one of the pins in the connector, but somebody here thought it would have been a better solution to use these coax cables. This is the next board. I would think this is IF module. Look at that, all sorts of modifications and coax cables for all the input-output stuff here. And that will of course be single sideband filters, and you can obviously plug in another one and select it, which one you want to use. We should probably try and open the shielded case so we can have a nice little look inside this unit. Yeah, quite a lot of modifications. Yeah, see what I'm saying? That is a nice single sideband crystal filter. Oh, we can open these boxes. So yeah, that one looks like the size you would use for FM. And we also got, what is that? Could be probably an FM demodulator or something like that. It definitely looks a lot like that. And so we got some IF going in here, and then we got another type of IF here, most likely for SSB or for AM or FM here, right? I'm just guessing. So here is a little audio amplifier to drive the loudspeaker, and there's most likely a little transformer here, so the output is completely isolated from everything. So that's pretty good. Did I tell you this entire unit here is 12 kilos? That's of course including top and bottom plates, but there's a reason why it's that heavy. This is iron plates, and this one is about 1 millimeter. Yeah, I think they're all about 1 millimeter thick. They are surface treated in such a way they are not corroding too much. But look at all the different shield plates here in between each of the circuit boards. That is very, very good for isolation and avoid all sorts of noise, crosstalk and all those kinds of issues. So that is a very, very good technical solution. And the next module is the PLL frequency synthesizers for all the different frequency bands. And see, here you got the reference oscillator, a good stable oscillator. There's even a, oh, this is impossible, November 82. Wow, so it's that old, huh? And this is a 2-layer board, by the way. You can see here we got all the nice layout, and they really tried to add as much grounding copper as they could on this layer as well, and it's of course carefully connected to the top layer, so this way they avoid radiation and pickup and all that kind of stuff. They're really trying their best. I think we should try and open some of those shielded units here. Oh, they are not even soldered, so I will try and carefully put them like that. So okay, we got 5 different frequency bands. You select probably some diodes or some transistors and stuff like that, right? You got some little amplifier modules. Can I open this one? Yes, I can. And again, we got 5 here. We got 5 different something going on here. That's probably one of the PLL chips. Got some more nice Motorola parts. But here we got only 4. That's interesting. There's like room for one more. Oh. What is that? I don't know exactly. Oh, see, we got another little crystal here. Okay, so mixing probably, right? Some reference oscillator and mixing stuff, and then let's have a look. And here we got 5 again. Yeah, okay. So we got some final stages, amplifiers, and extra filters for the probably the outputs, right? Or maybe it's the outputs here. I don't know. We probably got some both for the transmitters and receivers. So that's probably why we got all these double and something like that, right? But it's quite interesting how this is done. This took quite a while to design, and it's a huge board. So when you're looking down here, look at that nasty corrosion. Everything down there is just one big shorted nasty corrosion. So that is probably why this unit was thrown out. Everything here is just that is bad. We're probably gonna see more about that when we take out the we're gonna go down there and have a look. I think this is the last module. Yeah, it is the last module. So this is the transmitter, of course. And the fun thing is they're reusing, or well, they're not reusing the same crystal filters for the RX as for the TX. So that's a little bit interesting. This is what you normally see in ham radio stations. They only got one filter and it's used for transmitter and receiver. But here they got 2 different filters, and that is of course for different bandwidth. And you'll see here, this is the transmitter output broadband transformers, and they're driving and pre-driving and all that kind of stuff. Oh, we got some broadband amplifier modules as well. Okay, all this stuff here is broadband amplifiers, little crystal filter and stuff like that, yeah. And it's also a 2-sided board. And we got a little bit of digital interface, a little bit of control, probably just some latched drivers so you can remote control. Yeah, you see, that will be some 8-bit latches so you can control different settings and different filters and whatnot. And here's the motherboard at the bottom of the unit. It looks like with these little brass parts here, I would assume we are missing a bottom shielded plate that will completely shield and lock in everything in here. Because remember, originally all the RF tracks, they were just in those nice tracks, but somebody here improved it by adding little coax cables between the different modules. Quite a lot of modifications, right? I really can't wait to show you the front module. So here is the front plate and all the switches and readouts. It's also full of latched control circuits here, so of course you can imagine we need a lot more wires to handle all the readouts and all the switches and all that kind of stuff. So that's of course because there is a little serial interface, and then it will control and drive all those chips. But what I really wanted to see that is this. This is just beautiful. Look at that. So is this laser cut or mechanically cut? And then there is this 2-channel fork sensor to make the gray code out of this. So it's a rotary encoder. Isn't that just beautiful? Somehow there's a bearing in here and some mega weight inside this one. When you move this, you see it continues. So it's really, really heavy. this one is really interesting. So this is the antenna tune. But what the heck is that? It's just rotating a spring. Nothing more. I mean, what the heck is that doing? There's nothing in here, so this I don't understand. Yeah, it looks like something's been removed and then just this added. I don't know. Weird. So here is the brain. Just took out a nice little shield here. And here you go. Let's go straight to it. The Z80 CPU from 82. How nice. And the EEPROM with the software, of course. We got some interface circuits. So like an interface IC there. And that will be Z80 parallel input outputs. And yeah, just some line drivers. That's more or less all there is to it here. And a battery backup. And that will be the memory for the battery backup. So RAM is static RAM backed up. How cool is that? The funny thing is, this board is not plugged directly down to the motherboard. They could have made this board with a little connector down here, but instead they insisted on all those cables, all those connectors. Look at that. Why the heck would you choose to do it that way? And all this here could also have been with a connector at the side connecting down into this. I mean, this is a nightmare for all sorts of productions and all sorts of anything. It's just a bad idea. Oh, that will be volume. Okay, so I give up. Okay, volume is good to have in a nice shielded cable. Fantastic. But anyway, that is just great. I would not have made it with all those cables and connectors. Oh no, it's bad. Inside the rear panel, we just got 3 voltage regulators for 12 volt and 5 volt and some 8 volt. And I had the idea this one would could have been the input, but I'm actually happy that I really double checked everything before I just power up something here. Because this is 12 volt output, not input. This is connected to the output of this regulator here. So if I tried to put in something here, I could have blown up everything here. So there is a DB15 connector here. And this one is the interconnect to the transmitter module. And not only is it power, so we got a ground and 3 different voltages, 15 and 9 and 9. It actually set here on the circuit board here 9, 9 and 15. But in the manual, it's all wrong. This is 5 volts and all sorts of stuff that is completely wrong. Also on peel.dk, you can find all the manuals, schematics and all that. And there's also a PDF file that shows how to hardwire this one for standalone operation. We got 2 different transmit-receive signals here, and they need to be crossed. So this unit here sees something or get an answer, and then it will work. I hope so. This is the output stage, so there's a little pre-driver. But I mean, look at that one. That is a hefty driver. So this one is like 50 watts or something like that, right? But there isn't any heatsink here, or maybe somebody's removed the heatsink. So I probably shouldn't load it with that many watts. Also some pretty thin wires. There's one more thing to show you here on the inside. I had the idea we could connect some other modules here on the top, but no. Look what that is. That is a spare interconnect. If you take this out, this one here is used to plug in each of the individual modules to the motherboard, and then you can have it out here, out and up, so you can access both sides and do all sorts of service, measurements, adjustments, alignments, whatever you want to do. I think that is really nice. I love these service parts. You will find them inside some of the really high-end products like HP and something like that. You'll find these sometimes. So, after a little look around with all these connections and all that kind of stuff, I found a DB15, and then I am now ready to power it up. And look at that. We did see some little blinkety blink. And that is all. Let's try again. See, it powers up here and then. Oh. So it is trying to do something. Function is off, right? DX. Dimmer. No. It seems to be completely broken. But of course, I didn't expect more. It is using 17 watts at the moment. It does definitely power up. Yeah, I'm not going to repair it any more than that anyway. It was fun to try and see if I could power it up. It's just completely dead. Bad luck. Anyway, that is what I wanted to show you. Thank you very much for watching, and please come back soon. Bye bye.